about the compounding concept, differential pulse code modulation concept. What is the mean by compounding in the PCM system? Basically, compounding is the non-uniform quantizer are difficult to make and expensive, and it is the alternative is to first pass the speech signal through the non-linearly before the quantizing with the uniform quantizer. And basically the compounding is nothing but compression of the signal at the input side and expansion of the signal at the output side. And basically this is the non-linearity causes the signal amplitude to be compressed. The input to the quantizer will have more uniform distribution, and at the receiver the signal, in case of the receiver, the signal is expanded by the inverse to the non-linearity. The process of compressing and the expanding is called as the compounding. This is the waveform. This waveform is able to show the input voltage compounder and output voltage compounder. The blue line itself, it will be showing the compression technique. It will be compressed at the input side and it will be expansion at the output side of the system. Then here in the basic block diagram, there are the three stages to combine give the characteristics of the non-uniform quantizer technique. In case of the non-uniform quantizer technique, basically the compressor, uniform quantizer and the expander should be given. In the compressor, it will be able to compress the signal. M of t is the input signal and m bar of t is the output signal. And basically the m of t, which is equal to m bar of t at the once we have able to process the data successfully, then the compressor is able to compress the signal, and after that it will be uniform quantization. Either it is the mid-trade or mid-rise type of the quantization will be happen, and at the end we have expand the signal at the output side on both the axes, first and the third quadrant. And the three stages to combine give the characteristics of the non-uniform quantizer. Basically the non-uniform quantizer, it will be categorized as the step size is not a uniform or fixed. Then in case of the mu law compounding, in non-uniform compounding is basically classified into the two types, that is the A law compounding and the mu law compounding. In case of the mu law compounding for the speech signal, normally for the speech and the music signal, for A law compression is used. Means basic application of the compounding for the speech signal, that is in case of speech and music signal, for the mu law compression is used. And this compression is defined in the following equation, that is the z of x, which is equal to sine of x into natural logarithm of 1 plus mu mod of x upon natural logarithm of 1 plus mu, where mod of x should be less than or equal to 1. Then from this figure, in this figure, with the compounding and without the compounding, what happens? There is a constant characteristic should be happen, means signal to noise ratio should be constant throughout the process. But without compounding, it will be able to increases linearly. Means once the signal level is going to be increases, then the signal to noise ratio is also increases. Means from this PCM performed with the mu law compounding, the below figure shows the variation of the signal to noise ratio with respect to the signal level without compounding and with compounding. In case without compounding, it linearly changes the characteristics, but with compounding, here is the constant signal to noise ratio throughout the signal level. Then it can be observed from the above figure, the signal to noise ratio of the PCM remains almost constant with the compounding. Then A law compounding. In case of the A law compounding is generally used for Russia, Japan in this way, and A law provides the piecewise compressor characteristics. It has the linear segment for the low input and the logarithmic segment for the high level input. Means where z of x, which is to be calculated a mod of x upon 1 plus natural logarithm of a, where mod of x should be greater than or equal to 0 but less than or equal to 1 upon a. Then if the value is in between 1 upon a to 1, then its value should be calculated with the help of 1 plus natural logarithm of a mod of x upon 1 plus natural logarithm of a, for mod of x should be greater than or equal to 1 upon a should be less than or equal to 1. When a which is equal to 1, then we get the uniform quantization, and the practical value of the a should be 87.56 for both a and log compounding is used for the PCM telephone system. But in ordinary, the value of the mu should be varying from 0 to 255. Then we move towards the signal to noise ratio of the compounded PCM. Then the signal to noise ratio for the compounded PCM is given as, which is to be given signal to noise ratio which is equal to 3q square upon natural logarithm of 1 plus mu bracket raised to square, where q is the quantization level which is equal to 2 raised to v is the number of the quantization level should be calculated. Then from this figure we have understand that there is a characteristics between the input to the output, and when the mu which is equal to 0, there is a linear characteristic should be obtained. The value of mu should be varying from 0 to 1000. Then the compression characteristic should be obtained here. Means both way, the a which is equal to 87.6 and the mu which is equal to 255. Then the perfectly the constant signal to noise ratio should be obtained in case of mu and a log. Then next part, that is the differential pulse code modulation system. Then the differential pulse code modulation system, basically in case of the pulse code modulation, in case of the quantization, there is a redundant bit should be obtained, and with the help of the quantizer we have able to remove the redundant bit in the PCM system. The samples of the signals are highly corrected with each other, and this is because any signal does not change fast. That is, its value from present sample to the next sample does not differ by the large amount. Hence the adjacent sample of the signal carry the same information with the little difference. When these samples are encoded by the standard PCM system, the resultant encoded signal contains the redundant information, and that redundant information is useless. Hence there is a necessary to removing it. Then from with the help of the figure shows the continuous time signal x of t by the dotted line here. X of t signal should be shown by the dotted line, and here the signal xt, this signal is sampled by the flat top sampling. Flat top sampling means palm waveform. There is a pulse amplitude modulation waveform, and having its time duration should be changes from Ts, 2 Ts, 3 Ts up to the n number of the Ts, and the sampling frequency is selected to be higher than the Nyquist rate. Then the samples are denoted by the 3-bit or 7 levels. Here 3-bit means 2 raised to 3 means 0 to 7 levels we have obtained from the PCM system. Then the sample is quantized to the nearest digital value is as shown. From this figure, here is the redundant information. Suppose 100, here is again 100 is obtained. There is a 010, 101, again here is a 101 is obtained. Again here also 101, 101, then 110. These are all are the redundant information, and that redundant information should be coded by 0, that is the 000 up to the 7, there is a 111. These bit levels should be represented here. Then the principle of the DPCM, there is a differential pulse code modulation. If these frequencies are reduced, then the overall bit rate will be decreased, and the number of the bits to be transmitted one sample will also be reduced. And this type of the digital pulse modulation scheme is called as the differential pulse code modulation. Means if this redundant bit is reduced, then overall bit rate is also decreases, and number of the bits should be required to be transmit from one sample, it is also going to be decreases. Means basically whatever the bandwidth requirement, there is a bandwidth requirement is also reduced. Then there is a DPCM transmitter. Here is the DPCM transmitter. First we try to understand which blocks is contained in a differential pulse code modulation. Here is the sampled input. That sampled input is given to the comparator. Comparator means basically this comparator is nothing but it is the summing amplifier. The output of the comparator is given to the quantizer. Then quantizer, it will be quantize the value, approximation value, that will be given to the encoder, and simultaneously that bit is able to transmitted by the summing amplifier. Then there is the prediction filter. That prediction filter is to predict the redundant bit and will be able to removing it. This is the basic block diagram. This is the basic block diagram of the differential pulse code modulation transmitter. Then the differential pulse code modulation work on the principle of the prediction. The value of the present sample is predicted from the past sample. Means in case of the DPCM, the concept behind it, the value of the present sample is predicted from the past sample, and the prediction may not be exact, but it is very close to the actual sample value. Therefore, the transmitter of the differential pulse code modulation system, the sample signal is denoted by xn of ts. This is the sample signal, and the predicted signal, this predicted signal is represented by x dash n of ts. Then the comparator find out the difference between the actual sample value and the predicted sample value, and this is called as an error. If both the values should be equal, then error which is equal to 0. If it is not equal, then error should be introduced, and this error is denoted by En of ts, which is given by the difference between actual value, actual sampled value minus predicted value. This is given the equation number 1. Then thus this error output is the unquantized input signal or unquantized input sample. There is xn of ts and prediction value of x dash of n of ts. This is the x dash of n of ts. Okay, and the quantized output signal, means this is the quantized output signal. This quantized output signal and previous prediction is added. This will be given as the input prediction filter. This will be given to the input prediction filter, means this output should be given to the here, means this prediction value and the output of the quantizer, that will be given to the comparator, and output of the comparator is given to the prediction filter. Then after given the prediction filter, the signal xqn of ts, this makes the prediction more and more closely the actual sample signal, means the output from here xq of n of ts. This is very close to this signal. There is a xn of ts, means actual input signal. Then this makes the prediction more and more close to the actual sample signal. Then we can see that the quantized error signal eq n of ts is very small, and that can be encoded by using the small number of the bits. Thus number of the bits per sample are reduced in the differential pulse code modulation. Then quantizer output can be written as, the quantizer output is written eq of n of ts, which is equal to en of ts plus q n of ts. Means from this figure, en of ts plus q n of ts, this will be given to the here, means addition of the both. Then qn of ts is the quantizer error, and according to the figure, the prediction filter input xqn of ts is denoted by the sum of x dash of n of ts and quantizer output. Therefore xq n of ts, which is equal to x dash n of ts plus eq n of ts. This is the equation number 3. Then putting the value of eq of n of ts from equation number 2 in the equation number 3. Then the value of EQ n of Ts, this will be able to substitute here. Then this equation will be begins xq n of Ts, which is equal to x dash of n of Ts plus E n of Ts plus q n of Ts. This is the equation number 4. Then equation number 1 is the written as, equation number 1 is the difference. Here there is a E n of Ts, there is a error which is equal to x n of Ts minus x dash of n of Ts. Means we have calculated here the value, there is a x q of n of Ts. Then equation 1 is written as E n of Ts, which is equal to x n of Ts minus x dash of n of Ts. Therefore we calculated x n of Ts, means this value x n of Ts. There is a sampled input signal we have calculated here. Then x n of Ts, which is equal to E n of Ts plus x dash n of Ts. Then putting the value of E n of Ts plus x dash n of Ts from above equation into the equation number 4. In the equation number 4, we have substitute the value of x n of Ts. Okay. Then xq of n of Ts, which is equal to here E of n of Ts plus x dash of n of Ts, which is equal to x of n of Ts. Therefore xq of n of Ts, which is equal to x n of Ts plus q n of Ts. There is a q n of Ts. This is the equation number 6. Then this quantized version of the signal xq n of Ts is the sum of the original sample value plus quantized error, and the quantization error can be positive or negative from the equation number 6. It does not depend on the production filter characteristics. Then the reconstruction of the DPCM signal, how to deconstruct. Then DPCM input should be given to the decoder. Then this is the summing amplifier. The output is given to the production filter. The output of the production filter and the decoder will be calculated here. Then with the help of this figure, the decoder first reconstruct the quantized error signal from the incoming binary signal. Then the production filter output and quantized error signal are summed up to give the quantized version of the original signal. And the signal is the receiver differs from actual signal quantization error, which is introduced permanently in the reconstructed signal. Then up to this we have seen the differential pulse code modulation signal, modulation, demodulation. Then we have seen in previously there is a law, mu law here, companding in the PCM system, then its working, then mu law, A law, then signal to noise ratio in the PCM system, then differential pulse code modulation system, what is the necessity of the differential pulse code modulation system, then principle behind it, then how to work the DPCM transmitter, then how to reconstruct the DPCM signal. Up to this point we have seen the pulse code modulation. But once the signal is generated from the pulse code modulation system, it is in the form of the digital signals or binary signals, either logic 0 and logic 1. Then we move towards the line coding. In case of the line coding, in telecommunication, the line code is the code chosen for use within the communication system for the transmission of the digital signal down a transmission line. Line coding is often used for the digital data transport, and the waveform pattern of the voltage or current used to represent the ones and zeros of the digital signal on transmission link is called as the line encoding. Then line encoding are the unipolar, polar, bipolar and the Manchester encoding. Then the line codings are used commonly in the computer communication network over the short distance communication. Then how For sample purpose, we have take the binary data. There is a 1 0 1 0 1 1 0 0 1 0. Then here is the non-return to the 0. Means once the digital data is transmitted by 1, then its amplitude level should be returned to the 0. Then here is the 0 signal. Okay. Then if the transition between 0 to 1, again its amplitude should be going to be increased. Still it is not returned to the 0. It still remains once the logic 1 is transmitted. Then in the 0, during the transmission from 1 to the 0, its amplitude, this amplitude should be come to the 0. Then 0 to 1, 1 to 0, this transition should be happen for non-return 0 L type of the digital data. Then after that, non-return 0 for the Manchester. Means in case of the non-return to the 0, there is a 1 0, there is a 1, should remains it is 1 and transition from 0 to 1 only. Then 1 0, here is a 0 1, again here logic 1 still remains it is again 0 again 1. Means in this way this signal is able to start. Then return to the 0. In case of the return to the 0, here is the logic 1, amplitude should be 1, and once it will become then a complete one cycle, there is a 1 and 0. If it is 0 0, then 0, again 1, here is a 1, and up to the here we consider there is a single pulse for the logic 1. Then a biphase, here is the biphase, then biphase M, biphase S, differential Manchester should be given here, and bipolar. Bipolar means here is the positive as well as the negative signal should be happen, and this is called as the line code, which is used in the communication. Then its signal and its comment should be given where to be used. The NRZL is the non-return to 0 level. Means NRZL, L stands for return to 0 level, and this is the standard positive logic signal format used in the digital circuit. 1 is the forces for the high level and 0 is the forces to the low level. Then NRZM, non-return to 0 mark, means 1 force for the transition and 0 is nothing. Then NRZS means non-return to 0 space, means 1 does nothing, 0 forces a transition, means 0 to 1. Then RZ return to 0, 1 goes high for half the beat period and 0 does nothing. Then biphase L, there is a Manchester, 2 consecutive beats of the name and the type of the force in the transition at the beginning of the beat period. Then 1 forces the negative transition in the middle of the beat and 0 forces a positive transition in the middle of the beat. Then there are always a transition for the next, there is always a transition at the beginning of the beat period. There is a 1 forces a transition in the middle of the beat and 0 does nothing. Then there is a biphase, yes, there is a biphase for the 0 space, there are always a transition at the beginning of the beat period. Then differential Manchester, there is always a transition in the middle of the beat period. 1 does nothing but 0 forces a transition at the beginning of the beat. And the bipolar, the positive and negative pulses are the alternate. Means logic 1 forces the positive or negative pulse of the half of the beat period and 0 does nothing. Means up to the here we have understand that the basic concept behind of the differential pulse code modulation system, then its block diagram, and then how it will be able to work in the differential pulse code modulation techniques, and which are the line codes, how it will be companding in non-uniform quantization, what is the advantages of that, then A law and mu law, which country is adopted for A law, which country is adopted for the mu law. that part we have seen in this video. If any query, any suggestions, please write on my comment page. Please subscribe my channel and click on my bell icon. Have a nice day.